All right, so you've done it. You've built a killer machine learning model. But now what? That's the big question, right? Today, we're diving into what's arguably the most critical step, actually getting your model out into the real world. We're going to break down the three main deployment patterns that really separate these successful AI projects from the ones that just, well, become expensive failures. And I'm serious, this is the exact spot where so many brilliant projects just grind to a halt. You know that feeling? The gap between a model that looks amazing in a Jupyter notebook and one that's actually out there, delivering real value in a production environment, it's huge. It's a chasm. And how you decide to cross that chasm, well, that's what determines everything. And listen, the stakes here could not be higher. Picking the wrong deployment pattern, that's not just some small technical mistake. No, it's a full-on business catastrophe just waiting to happen. We're talking about literally burning through your cloud budget with clunky, inefficient infrastructure. Or even worse, delivering an app that's so painfully slow, your users just give up and leave. It's a really big deal. Okay, but don't worry, you're not navigating this blind. The good news is, the industry has pretty much settled on three core patterns to solve this exact problem. So let's meet the big three, the solutions that really form the foundation of modern MLOps. So this table here just lays it all out, right? It's all about the fundamental trade-offs. On one side, you've got batch inference. Yeah, it's slow, we're talking minutes, maybe even hours, but it's an absolute beast when it comes to chewing through huge data sets. Then, on the complete opposite end of the spectrum, you've got real-time inference. We're talking milliseconds, blazing fast for those small, urgent requests. And right there in the middle, you have streaming, which is designed for that constant, never-ending flow of incoming data. It really all boils down to that classic balancing act between speed and scale. All right, so now that we've got the lay of the land, let's see these patterns out in the wild. We're going to dive into the specific use cases where each one is the clear, undisputed champion. First up is batch inference. The best way to think about this one is as your scheduled heavy lifter. It's perfect for when you need to run predictions on your entire dataset, but you don't need them, this very second. This is the kind of job you'd orchestrate with something like Apache Airflow or run on a big data platform like Spark. We're talking about things like calculating all the credit risk scores for your customers overnight or refreshing everyone's product recommendations every morning. For that stuff, batch is, hands down, the most cost-effective way to get it done. Okay, now let's jump to the complete other end of the universe, real-time inference. This is all about one thing, immediacy. When a user is sitting there waiting, you need an answer right now. Like, we're talking under 100 milliseconds. This is the magic behind the fraud detection system that approves your credit card swipe in an instant, or the chatbot that feels like you're talking to a real person. And how does it work? Well, usually you're wrapping your model in something like a REST API and deploying it as an always-on microservice, maybe on a platform like AWS SageMaker or Kubernetes. And then, bridging that gap between batch and real-time, you've got streaming inference. This one is built for data that just never, ever stops. Just imagine data pouring in from IoT sensors or stock market tickers updating every second, or just a fire hose of social media posts. The model has to process all of these events as they arrive in near real time. This pattern, often powered by tech like Apache Flink or Kafka Streams, is really the perfect middle ground. It's not quite as instantaneous as pure real time, but it's designed for this constant flow, making sure you're always acting on the absolute latest information. So, okay. You know the patterns now, but the million-dollar question is, how do you choose the right one for your project? Well, let's walk through a super simple but really powerful three-question framework that's going to guide you straight to the right answer. Question number one, and this is the big one, is a human waiting? Is your model part of some interactive experience where a user is literally staring at their screen, expecting an immediate response? If the answer to that is a clear yes, well, your decision is pretty much made for you. User experience is everything here, and that means you absolutely need the sub-second latency that only real-time inference can give you. There's really no other choice. Okay, so what if nobody's actively waiting? That brings us to question number two, which is all about the nature of your data. Is your data arriving continuously, like an unbounded stream of events that just keeps on coming? If that sounds like your world, constant sensor readings, endless log files, nonstop transaction data, then you've just entered the domain of streaming inference. You need a system that can process these events on the fly, just to keep its head above water. And finally, if it's not directly user-facing and it's not a continuous stream, then you ask yourself the last question. Are you just running predictions on a fixed schedule, say once a day or once a week? And is keeping that cloud bill as low as possible a major priority for you? If that's your scenario, then batch inference is your new best friend. It's designed specifically to spin up a bunch of resources, chew through a massive amount of data super efficiently, and then just spin right back down. It is by far the most cost-effective way to handle those large-scale, non-urgent jobs.
Okay, great. So now we know how to choose the right pattern. But let's talk about execution, because trust me, making the right choice is only half the battle. So now we're going to cover the common pitfalls to avoid and the best practices that are going to set you up for success.
So let's talk about what can go wrong. The number one mistake I see, over-engineering. People paying for an expensive, always-on, real-time endpoint for a job that could have easily been done with a cheap batch process overnight. It's like using a sledgehammer to crack a nut. Or you've got the opposite problem, trying to detect real-time fraud with a batch job that only runs once a day. I mean, come on. These aren't just little technical goofs. They are the silent killers of ML projects. They just waste money and completely fail to deliver on their promise. So the key here is to just flip those mistakes on their head and turn them into best practices. First, always start with the business need, not the cool new tech. Then you need to obsessively track your key metrics. I'm talking latency, throughput, and especially cost. Automate everything you possibly can with CI/CD pipelines, use a model registry to manage your versions like a real software project, and this is so important, you have to monitor for data drift and performance drops. Remember, a model is a living, breathing thing. It's not a set it and forget it kind of deal.
Yeah, this quote right here it perfectly sums up everything we've been talking about. Bad deployment kills good models. It's so true. You can have the most brilliant model in the world with 99% accuracy, but if the deployment is unreliable or slow or insecure, that model is completely worthless. The deployment strategy is what actually unlocks the model's potential and turns all that cool math into real, tangible business value. And that really brings us to the most important takeaway of all. The decision between batch, streaming, or real-time, it's not just a technical choice. It's a strategic business decision. So before you get lost choosing a tool or designing an architecture, just stop and ask yourself, what does the business truly need here? Do we need a flawless user experience? Do we need maximum cost efficiency? Or do we need up-to-the-second insights? Let that answer guide your hand, and I promise you will not go wrong.